ठीक है. So that is why this is the relevance and that's why we have initially kept that रिवर वाला जो कॉन्सेप्ट है उसमें आप फ्लैट प्लेन भी, फिर से मैं बोल रहा हूँ, रिवर से फ्लैट प्लेन को अलग मत कीजिए. फ्लैट प्लेन इज विद इन द रिवर एंड रिवर फ्लैट प्लेन से अलग नहीं है. दैट इज वी आर वर्किंग ऑन द IIRA R7 मॉडल. दैट इज द रीथिंकिंग ऑफ द रिवर थ्रू द एम्ब्रेसिंग द न्यू पर्सपेक्टिव. रीजेनरेट, दैट इज द रेस्टोरिंग द नेचुरल इकोसिस्टम. ये हमारे लिए अभी आज चैलेंज बन गया है. मान लीजिए ये हमारे लिए चैलेंज की बात ही नहीं है, क्योंकि ये हमारे we are fortunate that so much rivers we have. Not only I am talking about Assam or any West Bengal, I am talking about whole country. If we consider the flowing water, अगर आप मान लीजिए सिर्फ वाटर सिक्योरिटी के बाद हम करते रहते, इतना सेमिनार रहता है वाटर सिक्योरिटी के ऊपर. मोस्ट ऑफ द केसेस वी आर फोकसिंग द वाटर सिक्योरिटी, दैट इज द ग्राउंड वाटर क्या है. वी आर नॉट फोकसिंग इवन इन ए सिंगल लाइन के अरे ये हमारे सामने जो नदी फ्लो हो रहा है इसमें जो पानी है इसको अगर हम एक एक फर्स्ट ऑर्डर सेकंड ऑर्डर करके हर एक स्ट्रीम को अगर हम प्रोटेक्ट करना शुरू कर दे, जितना वाटर हमें है अगले 500 सालों तक मैं बोल सकता हूं कि हमारे वाटर सिक्योरिटी के इशू ही नहीं आ सकता है. लेकिन हम वाटर सिक्योरिटी मतलब ग्राउंड वाटर के ऊपर फोकस करते हैं. एंड आई थिंक दिस शुड बी इन जो मुझे लगता है जितने जैसे रिवर सेंसस के बारे में बताया, सारे रिवर का कितना बेसिन है, कितना बेसिन साइज क्या है, उसका फ्लैट प्लेन एरिया क्या है, उसमें कितना वॉल्यूम ऑफ वाटर कंज्यूम कर सकते हैं, सारे का एक डेटाबेस, डिजिटल डेटाबेस वी शुड प्रिपेयर थ्रू दिस जॉइंट इनिशिएटिव. एंड मैं नहीं बोल रहा हूं कि ये सिर्फ निहारी का काम है, ये CWC का काम है. इट्स द ड्यूटी ऑफ ऑल ऑफ अस, ऑर्गेनाइजेशंस लाइक अस. ऑब्वियसली आई एम नॉट द गवर्नमेंट बट वी आर वर्किंग विद द गवर्नमेंट. सो आई नो दैट ब्यूरोक्रेसी जो भी होता है, पॉलिसी होता है, एक डायरेक्टर जितने भी प्रेशर है, बट ये सारे काम भी अगर हम एक बार तैयार कर लिए डेटाबेस, इट विल बी ह्यूज डेटाबेस. एंड स्टिल नाउ नो अदर कंट्रीज इज फोकसिंग ऑन दैट सच काइंड ऑफ डेटाबेस व्हाट वी कैन डू. सो जैसे R7 का 3 जो है दैट इज द रेजुमिनेट. व्हाट आर द रिवर्स वी हैव ऑलरेडी लॉस्ट बिकॉज यू नो द रिवर आर मोस्टली फोकसिंग facing the encroachment problems. The flood plains are mostly facing the encroachment problems. So rejuvenation is very much important. And I am happy to share through this platform that recently we got a project from the Namami Gange, because through my inquisitiveness, I have founded several previous river maps that was being prepared by James Reynolds, the Surveyor General of India, from in 1876, like that. So, उन मैप को हमने कलेक्ट किया. मैंने डीजी के साथ मीटिंग किया कि सर ये हमारा प्रीवियस बेंचमार्क है, तो इसको हमें इमीडिएटली डिजिटाइज करना पड़ेगा, ताकि अभी जो नया रिवर्स है, आप रेजुमिनेशन की बात कर रहे हैं, अभी जो नया रिवर्स है उनको अगर हम सुपर इम्पोज करें सैटेलाइट इमेज के थ्रू से, वी कैन इमीडिएटली ट्रैक कौन सा रिवर था, कौन सा रिवर नहीं है. तो ये अगर है तो आपका जो रेजुमिनेशन वाला पॉलिसी है मिनिस्ट्री का, वी कैन टेक इट एज ए पॉलिसी. एंड ये मैं सिर्फ अपने नेशनल लेवल के नहीं बोल रहा हूँ, बंगाल के, मैंने बंगाल गंगा डेल्टा के बारे में बताया. ऐसा है जो ब्रह्मपुत्र पूरा जो बेसिन एरिया है, ऐसा भी अगर हम एक बार पुराना मैप सर्च करके उसके ऊपर सुपर इम्पोज कर सकते हैं, तो वी कैन इमीडिएटली फाइंड आउट दैट एरियाज. एंड यू विल ऑल्सो बी, आई थिंक यू नो दैट DOL, डिपार्टमेंट ऑफ लैंड रिसोर्स ऑफ द मिनिस्टर ऑफ रूरल डेवलपमेंट, दे आर ऑल्सो टेकिंग वन इनिशिएटिव दैट इज द माइक्रो वाटरशेड मैनेजमेंट, माइक्रो रिवर वाटरशेड रेजुमिनेशन एंड मैनेजमेंट. दैट इज ऑन द बेस्ड ऑफ द नेचुरल नेचर बेस्ड सोल्यूशन, बिकॉज दे आर थिंकिंग जो फ्लैट प्लेन एरिया अभी साल में 6 महीने सूखा रहता है, उसको अगर हम 6 महीने से नेचर बेस्ड सोल्यूशन करके किसी भी कारण उसके पानी जो भी है कम है, तो उसको अगर हम रेजुविनेट कर सके, एटलीस्ट 2 महीना ज्यादा पानी दे सके, तो उस पानी और भी काम आ सकता है. तो दिस इज द प्रोसेस दैट इज द रेजुविनेशन एंड कॉल्ड द रिवैम्प ऑफ द मॉडर्नाइजिंग इंफ्रास्ट्रक्चर. Next, recycling of the sustainable water use, that is also very important. And remodeling करके, अगर अभी digital twin आ गया है, अभी beam technology आ गया है, why not we focus on the creation of the digital twin model of the rivers? तो वो भी कर सकते हैं. इनफैक्ट आपको यूनिवर्सिटी ऑफ मैसाचुसेट्स के बारे में पता है, सो दे आर ऑल्सो वर्किंग सच काइंड ऑफ इनिशिएटिव ऑन द 3D मॉडलिंग ऑफ द रिवर. एंड ऑब्वियसली द लास्ट एंड मोस्ट इंपॉर्टेंट, दैट इज द रिकनेक्ट, connecting people, connecting community. And डेका सर से मेरा आने से पहले ही वही बात हो रहा था, how we should connect the community, because it's, as I said, that it is not only our job, it is the job of that. And as you are coming from the different state government, we almost are associated with the public, dealings with the public. So we should take an initiative, we should develop one wing under the every ministry or every state government, that river should be a part, and that part should deal whatever the river you have in your state, whatever the river water resources you have in your state, डेटा क्रिएशन से शुरू करके जो जो रिवर अभी नहीं है उसको कैसे हम रिजुविनेट कर सके. अल्टीमेटली देन द कॉन्सेप्ट ऑफ द फ्लैट प्लेन जो पॉलिसी आज हम बात कर रहे हैं या पॉलिसी इंप्लीमेंटेशन करने का या लाने का जो बात कर रहे हैं, देन इट विल बी मच मोर सक्सेसफुल. साथ में टेक्नोलॉजी तो डेफिनेटली इट्स एन इंटीग्रल पार्ट, जो टेक्नोलॉजी को हमको यूज करना ही पड़ेगा, क्योंकि विदाउट टेक्नोलॉजी आई डोंट थिंक इट इज वेरी मच रिक्वायर्ड टू डू दैट. तो आज का जो कॉन्सेप्ट दैट इज द एप्लीकेशन ऑफ जियोस्पेशियल टेक्नोलॉजी इन फ्लड जोनेशन एंड EAMS, ये हमारे अनिक जी हैं. अनिक जी हमारे साथ ही रिसर्च का काम करते हैं रिवर के ऊपर, हमारे रिवर सेंटर के साथ भी वो जुड़े हैं. तो आई वुड रिक्वेस्ट अनिक जी टू स्टार्ट दैट इनिशिएशन. ओवर टू यू.
Thank you, sir, for the wonderful session. From here, I will continue. What is platform zonation? You have already may know from the previous session that what is platform zonation, but what's the objective to doing that platform zonation? To what we know, as sir was saying, that the floods, we can't stop the floods. Okay, so what we need to do, what we can do that minimize the effect of that flood. For that, what we can do, we can identify the areas where the flood is generally occurred, or in the future we can predict that where flood can be occurred, and we can do the disaster management part for that. So the objective of the flood plan is the minimize the flood losses, guide the urban growth, and protect critical infrastructure, and improve the disaster resilience. So these platform zones are mainly divided into 3 zones: prohibited zones, restricted zones, and warning zones. Okay, so do you all for my session I will be giving you some glimpses of what, using the geospatial science and geospatial technology, what we can do in this river zonation part and the flood accessibility and flood inundation modeling, this kind of things. Okay, so do you any of you do know that how to demarcate the rivers, or using the geospatial techniques or something? Anyone? Yes. Do anyone knows that? So how you guys delineate the rivers?
From Google Earth, we can download the
Shapefile.
file.
Okay.
Installation can be done.
For that you can do what is already done. You are using the data. ठीक है, but how that shapefile is, how this shapefile is created? Okay, for that there are various softwares, for example ArcGIS, QGIS, this kind of. So what we will show that as no software is there, I can just tell you to how you can delineate that the river and the river basin. So to delineate, first you will need the dam. Now dam are of various types. There are SRTM dams, also Allos Pulsar dam, and various these kinds of dam. Also many institutes make their personalized dam also. So from the dam, what we do need to do, you can write it there, the process. So everyone, so from the dam, first we need to see that is there any blank space in the dam, because who is creating the dam, it's based on various data. If it is like, for example, SRTM dam, so that is a central government based dam which we can find in the IRS Bhuvan portal. Okay, in IRS Bhuvan portal. But problem is that the dam in the in that dam there some of the places are not there, means that the data is insufficient in some of the places because of terrain difficulties or this kind of things. So for that we for them this kind of softwares which are there, those use of generalized averaging out that area from the different places, adjoining places of the of the dam. So for that we need to go to the fill option in the ArcGIS. So dam, then fill. Now when we are doing the fill, sometimes there may be some geoprocessing errors. For that we need to on one of the feature which is parallel processing, we need to make it 0. So no parallel processing should be there. So dam, fill, then we will make the flow direction. Flow direction means in the dam what the data shows, the dam data is the elevation of various places. Okay, so in that dam, so in which regions, मतलब अगर कोई जगह पे अगर कोई रिवर है तो फिर तो उस जगह पे मतलब एलिवेशन बहुत ही कम होगा, तो उसमें कौन से डायरेक्शन से कौन से डायरेक्शन जा रहा है वो देखने के लिए हम जो करते हैं वो है फ्लो डायरेक्शन. ओके, सो फ्लो डायरेक्शन, देन वी नीड टू सी फ्लो accumulation. You can write that the process, that will be helpful for you. Then we will see that what is the range. When the flow accumulation file will come, we can see the color variations in those pixels. Okay, we need to identify what's the lowest color of pixel we can get. Majorly those will be in black, but what we need to find is what is the most in color white. Okay, so using identifier tool you can click on that and you can find the value of that place. Okay, the pixel value of this place. So the pixel value we need to write it down, and after that we need to go to the raster calculator, and there we need to make the flow accumulation below that number. So then there will be a polyline file that will come. Okay, but that won't be the shape file, that will be a raster format file. Okay, so to make the raster format file into shape file, what she is saying, so to make that we need to convert to the file into raster to polyline. Polyline means polygon, polyline, various things. So polygon is the area and polyline are the lines. Okay, this in the shape file. So we will need to convert that to the polyline. Okay, so thus we can get the river channel. Okay, the shape file you are saying that kind of shape file is made like this. Okay, here is the example of some of the stream order. Also after getting the shape file, from the raster file we can identify in which order the stream is, which is really important for analysis of the morphodynamics of the river channel. Okay, so here, so how this watershed and stream order of the river basin can be helpful to assess the flood zonation, socio-economic vulnerability and river flow dynamics of the river basins for enhancing the flood risk management strategies and support sustainable development planning. Okay, so I will be showing some of the GIS assessment framework using which we can do the flood susceptibility modeling or flood vulnerability modeling. Okay, so for the flood susceptibility there are various processes, starting from the very basic things, that is the FR, the frequency ratio. Also if we are getting in more details, in more realistical approach, that can be of multi-criteria decision making techniques, like logistic regression can be used, and for the MCDM techniques we can use the AHP, then random forest, this kind of techniques, which will integrate various factors which are responsible for the flood zonation and the flood susceptibility and flood vulnerability. So the integration of spatial overlay, integration of thematic layers, and for the calculation we will given some weightage on every factor and the various factors of for mapping for risk zones. Okay, so these are the layers which will be needed, which we can consider. In many places many things are differ due to the basic topology of that area. So which factor we need to select and which factor we shouldn't select, we need to do it by the survey or various kind of things. Which factors should we consider? For example, in some places maybe that can be from for an area कि वहाँ पे बहुत सारा बारिश हो रहा है, ठीक है, मतलब हर साल एक समय पर वहाँ पे बहुत ज्यादा बारिश होता है, तो तभी वहाँ पे फ्लड होता है. तो इसका मतलब है जो रेनफॉल का वेटेज है वो हमको ज्यादा देना पड़ेगा, क्योंकि जब रेनफॉल वहाँ पे नहीं हो रहा वहाँ पे उतना वेटेज नहीं लग रहा, उतना फ्लड नहीं हो रहा. दिस काइंड ऑफ. So I have already said this kind of things. The parameters, in the various parameters which we have already, I have said that we can select. Excuse me. आगे जाओ जाओ. नहीं पढ़े उठा आगे previous. Okay. Here are the GIS layers we are saying. So this kind of layers, for example, the elevation and the slope. ठीक है, तो slope करके चलिए कि मतलब जहाँ पे ज्यादा स्लोप होगा वहीं पे तो मतलब लैंडस्लाइड या फिर फ्लड होने का चांसेस ज्यादा रहेगा ना, बहुत ही ऑब्वियस चीज है. तो उसके लिए मतलब हम लोग एक स्लोप का मैप बनाएंगे. ठीक है, स्लोप का मैप बना के उसमें क्राइटेरिया डिसाइड कर देंगे. तो डिवाइड कर देंगे स्लोप्स को वेरियस जो ज्यादा स्लोप है एक रेंज लेके उस रेंज में डिवाइड कर देंगे. पकड़ के चलिए कि 1 से 6 डिग्री के लिए हमको लग रहा है कि यहाँ पे फ्लड होने के चांसेस कम है. ठीक है, तो वहां पे एक वेटेज देंगे और जिसमें फ्लड होने के चांसेस ज्यादा होंगे तो उसमें हम लोग दे देंगे कि ज्यादा वेटेज. ठीक है, तो इस तरह से हर जो भी यहाँ पे फैक्टर्स में बोल रहा हूँ, जो भी जीआईएस लेयर्स है, तो इन सब में एक वेटेज देना पड़ेगा. ठीक है, बट मैंने पहले क्या बोला था, पहले कि जो वेरियस फैक्टर्स है तो इसमें भी जो एलिवेशन है और स्लोप है इनको भी एक परसेंटेज देना पड़ेगा मुझको. मतलब हम दो जगह पे वेटेज दे रहे हैं, एक कौन सा फैक्टर ज्यादा इंपॉर्टेंट है, ठीक है, और वो फैक्टर्स में जो पैरामीटर्स में मैंने डिवाइड किया है उसमें से कौन सा ग्रुप में सबसे ज्यादा वाल्नरेबल है. ठीक है, वहां पे करेंगे. तो इस तरह से अगर हम इसमें इमेज ओवरले करेंगे, QGIS में कर सकते हैं, ArcGIS में कर सकते हैं, तो वहां से एक फ्लड ससेप्टिबिलिटी मॉडल निकल के आएगा. और अगर हम वेरियस ह्यूमन फैक्टर्स को भी कंसीडर करें तो फिर जो आएगा वो होगा एक वल्नरेबिलिटी. ओके, so various satellite data are available for Sentinel-1 SAR for cloud-free water detection and Sentinel-2 for optimal NDWI indices. And also, as I am what I am saying throughout the time are mainly from QGIS and ArcGIS, these kinds of things. Okay, but for the other parts we can also do it in Google Earth Engine. Okay, for that that is one of the most feasible options. So most feasible options, because for the Google Earth Engine we don't need to do the downloading part and the storage, because Google Earth Engine is a cloud based software. Okay, so for the Google cloud based, so it and just using by various codes we can delineate the basin and the this kind of and it's also really less time taking. Okay, so I will do this. So here is the GIS tools comparison. One is QGIS, which is a easy open source tool. RGIS also there, but that is cost efficient obviously because it's made by Esri and it's a private concern. Google Earth Engine is a open software using cloud-based satellite data processing software, and HECRAS, which is the hydraulic modeling software and flow simulation software mainly. So what we need to do, that update the maps, and we need to, what we are lacking at present, we can do this kind of things, but why still floods are happening and we are not being able to lessen the consequences? Because the data we have are majorly the previous data. We are not updating it, so we need to make and try to make something which will automatically make the with the change detection within the automated change detection and these kinds of things using various codings and these kinds of things. Here is the what I am saying in the previous sections, that these are the various factors which made using geoprocessing tools: the soil cover, the NDVI, the land use, land cover, annual rainfall, distance to roads, and submersion. Okay, so using overlaying all these layers, there are also others, these kinds of, what we will get a river basin for the flood zonation. Okay, the susceptibility mapping. So the red areas which are very high, here the red areas in this map, what we can see, the red areas, we are very highly susceptible to the flood. That means there shouldn't be too much people living in that place for precautionary measures in the future, because flood will definitely happen over that place surely. Similarly, in which are the very low areas, we can also identify that, so that are more safer for living in this area. Here the same kind of things are shown, the flood susceptibility mapping of this river basin, what the similar kind of things. And next, coming to the embankment assets management system. Okay, so what is embankment assets management system? It's a structure framework using technology and data to monitor and maintain optimal flood protection or transport embankments, ensuring safety, efficient and cost effective by tracking condition, predicting failures and guiding maintenance decisions for these critical infrastructure assets. So as sir was saying, that we can't lessen the amount of flood, but what we can do, that we can decrease the consequences from the flood. Okay, so this embankment assets management system is this kinds of the system, and the objective of this system is to ensure structural integrity and flood safety, create a single authoritative inventory of embankment assets, enable condition based and risk based maintenance, support informed budgeting prioritization, integrated real time monitoring and early warning. With this is a really important point, the real time monitoring part and the early warning system, for which we can guess where the flood effect can be the highest. Also, the improvement of interagency coordination and transparency, extend asset life and reduce long-term cost. Okay, for this embankment assets management, so the biggest problem in this floodplain zoning is that the restricting people to come in the high risk zones. Okay, so majorly high risk zones are the exact zones which are exactly beside the river beds, but you will find many people living in those beds, right? But what we can do, that maybe we can mitigate them to some other places, but then whenever land will be vacant, as the land is fertile, people will surely come. So some of the measures what we can do, that we can do a riverfront development, right? So that place will be also utilized for various things. Then this kind of precautionary measures we can find, and solutions we can find to what can be implemented from point of view. Now, geospatial technology in embankment access management can be done using drone for inspection, LiDAR surveys, IoT sensors, GIS-based dashboard. Okay, so I can say about one of the drones for inspection part. For example, do you have anyone heard about the concept of drone in a box? Okay, so drone in a box is a concept that the drone comes with the automated technology. Majorly, it's not at present in work in India, but some of the private organizations buy them for their various uses. This is mainly done for the illegal sand mining. So what we can do, that drone in the drone in a box concept, the drone comes in a box where we select the path of the drone. The drone at a time what we have selected, the drone comes from the box directly without anyone don't need to control it by anyone, because in sand mining the political risk is high. So that's why the drone comes by its own from the box at a specific time, and a pathway is already selected. The drone captures the images through the pathway, and again after a time it comes to the box and the box is closed. This kind of technologies can we use from the, and as I am saying that why the embankment assessment management is important. This is the case study in Mahananda River of Siliguri. So here this study is mainly to quantify the water quality index and how the river pollution is taking place within the upper course and the lower course within the Siliguri city. So in the red parts, what you can see, that is majorly the LULC. In the LULC part, that is majorly the Siliguri city parts and the extended Siliguri area. Okay, so you can see that the water quality is when the river water is in the urban stretches, the river quality deteriorates drastically, and in the upper course the areas are really less polluted. So the importance of the embankment access management is here, because as there are too much interventions in the rivers natural flow in the urban areas, the rivers get more polluted in that kind of area. But in the upper course, when the urban stretches and people are not there, the stretches are not that much polluted. Also you can see the narrowing down of the channel in the urban areas, these kinds of things. So what I was telling previously, application of drone in river management, the topographical mapping, rivers cross section profile, longitudinal profiles, the contour maps. I think as many of you are engineers, you guys do this kinds of thing using DigiPlace and various kinds of things, right? So why we need the floodplain zoning for better planning, reduces cost, for creation of policy framework combining zone and asset management and geospatial systems to strengthen the surveillance and decision making. So geospatial systems are not just everything, but at a part of thing using which the assessment and these kinds of management can be bettered. Thank you. I will be giving some of the codes in the group which you can use for the Google Earth engine and these kinds of things. You need to change something, for example the shape file. So for which river you are using, you need to give that shape file. That shape file you need to collect, and you can do the flood accessibility and flood inundation map, these kinds of things. I am sharing one of the things.
আর কিছু কি ক্লাস আছে?